Hello everyone. Hope you are doing extremely well. Let's start with the second part of the distributed message queue that we have been designing. In case you haven't seen the earlier part, there we have gone into really the granular detail of what exactly the difference between the streaming, giving, pops up, etc. And here what we will try to do is we will try to go into the actual design details, how in case we want to build a distributed message queue from scratch, what exactly we are going to do. So let's discuss the very basic components that we have discussed the other day, like the producer, broker, consumer, and what are the corresponding support system of that particular whole ecosystem, tech ecosystem would be. We will try to just draw them on a very high level, and from there what we will do is we will try to build up the data structures, APIs, and the other parts. So at first what we had is we had some producers. So these producers will produce the messages. From producer, the messages will go to the message broker, and this message broker is the thing that we are talking about here. The message broker is basically the like we can think a broker is basically the main Kafka which we talk about, like when we are sending some data from the producer, this broker is the one which handles it. Like it can queue, it can stream. There are other kind of details but we discussed the other day. And from here what will happen is this will go to the different consumer or the consumer groups. So here we can, like, whatever this thing we are doing here, that can be termed as consumer group. Okay, that can be termed as consumer group. Okay, so this is on a very high level, something will be there. But now the first thing that generally should come to our mind is where exactly this broker or our Kafka is going to store our data at. So this is again going to be like some a point of some brainstorming. So you can just pause the video and think through, and I will directly jump on the discussion. But generally, like ideally when you are learning about any system, what we should be doing is we probably should think through the problem a little bit, that what will be the underlying data structure. So let's discuss about that, like the underlying data storage. Okay, so the underlying data storage that we are talking about, the data storage can be of multiple types. Okay, it can have something like RDBMS, but you know, like RDBMS will be not appropriate for here, because the problem that will happen with the RDBMS is RDBMS RDBMS ideally is good for like general write heavy f- or for write heavy or for the read heavy cases, RDMS performance is always horrible. Okay, so for example, here we are looking for a lot of random IO, like a lot of messages will be read from at any point of time, like the message offset that we have been discussing. So here the particular data structure that we will be looking at is WAL, that is write ahead log. So what happens is write ahead log is again a completely different a different type of discussion that we have to go through if we have to discuss a lot about write ahead log. But generally what it does is it is sort of a append only log. It doesn't do any kind of update or deletion. What it keep on doing is it keep on appending into the log, and always the latest entry is being read. For example, if there is a key1, k1 is the key and v1 is the value, and again after some time what we will have is k1 is the key and the v2 is the value. This both of them will be persisted, but the latest one appended will be retrieved. Okay, this is the very idea of a WAL. So instead of RDBMS, what we will go through is we will go to WAL sort of a thing. And Apache Kafka, if we think about like what kind of data, what kind of underlying data structure it uses, it ideally uses WAL. Now, coming to our next set of things, that is how the message structure or the schema will design. So here we have the underlying data storage, and after underlying data storage, let's discuss about the schema. Okay. So what would be the schema of the message that we want to work on? So um, our schema will be like we should have a fixed schema sort of a thing, and that fixed schema, of course, it will have key and value. Key and value. This will be keep on getting inserted into our WL. Okay. So the main. So suppose this is kind of a storage or WL that we are using. So key value will keep on getting into WL, and there will be like some deserialization of this data will be required, and that deserialization will be the responsibility of the consuming client. So whoever will be consuming the value from our storage from our broker, they will deserialize it as per their own convenience or as per their own model. When we are sending this data, like whether we will be sending one by one, or like we can take our Kafka like this, what we can try to do is we can either send one by one, like here one message is there, then one message is there, and they all will be sent one by one. They all will be sent one by one. Or else what we can do is, we can batch all of them together. Like we take all of them together, and as a batch we can keep on sending. So whether we will do like a one by one throughput or a batching, this will be again sort of a decision that we can take on the runtime, but this is something that we should ponder about. That's why I just wrote it for the time being. So uh, just to brief out all our basic discussion that we did so far is we are going from a producer, and from producer we will have broker, and from broker we will go to the consumer group. And what we are going to have is like we are going to have a WAL or the write ahead logs. It will be like we have rejected the databases. What we will do is we will have a write ahead log, and probably perhaps batching based on like how high the throughput we needed. And this system is will be like if we scale it properly, probably millions of messages per second, it will be able to handle very easily. Now let's start with the producer flow. Okay. So how the producer flow would look like. So when the message is coming from a producer, so suppose there is a producer and any message is coming from this to a broker, in between what we should be having is we should be having a routing layer. So when I say routing layer, what this routing layer's responsibility will be, let's talk about. So a producer sends a message to a routing layer at first. So instead of broker, what will happen is it will come to the routing layer at first, and from the routing layer uh, it reads the kind of a distribution plan. So and this distribution there will be a distribution plan, and this distribution plan would make sure that in which part of this broker it will go. Like if you remember the other day we have discussed different things like topic, partitions, etc., right? So this this routing layer would decide where exactly it will go. So and also like this routing layer or while distributing these messages, what it will do is it will not really send the message to a single partition or a single topic. Rather than what it generally does is it will keep on uh, distributing to the replicas of it. Like if one partition is functioning, and instead of working, suppose this those partitions in some way are getting into a downtime. What will happen is, in that case, this replicas will take care of that. So there will be a sort of a lead replica, or instead of lead replica we can say that like a master replica sort of a thing, which will receive the message, and the follower replicas will pull data from the leader. So there will be lead replicas and there will be follower replicas. There will be like follower 1, follower 2, in this way. So this routing layer from this distribution plan, what will happen is, if suppose there is a message like this message will go to the routing layer. From the distribution plan, it will go to a lead replica, and from lead replica it will get replicated into different followers. Okay, follower 1, follower 2, it will keep on getting replicated here and there. And then further broker topic and partitions will come there, and their responsibilities will start. So the broker is primarily will be our leader replica, and what this will help is to reduce the latency. Like if in case the leader replica is up and running, then of course from the leader replica the rest of the topic partitions and the consumer groups can start working. Now let's talk about one more thing here. Like while this data is being processed, one very important concepts that comes here is buffering versus batching. So buffering is like temporarily storing a data into the memory before sending it to the next level, and batching involves grouping the multiple messages together and sending it to the single unit to improve latency. So again, buffering means temporarily storing the data before sending it to the next stage. Like you will see that YouTube buffers probably next 10 seconds of video every time that it temporarily stores the memory. And batching means, suppose you are uploading 15 photos in your Facebook account in some way. So what it does is it will batch all the 15 requests together, and in a way uh, it it kind of makes sure that all of them are getting succeeded all at once. So that is the difference between the batching and the buffering. Now what exactly the producer buffering here is? So producer buffering means that producer collects the message in a buffer before sending them to the broker. Okay, and batching means that once the buffer reaches its certain size of limit. So buffer is producer collecting the message in memory. Okay, and batching means once buffer reaches a certain size, producer sends P stands for producer here, sends the whole batch of buffered message. So this is again like there is a buffering limit that we give, and what we keep on doing is we keep on sending that data to our we keep on sending that particular data to our broker. So and one of the example would be, suppose you think of about Uber. Okay, in Uber what happens is the users are sending some ride request, in a day, suppose like 31st December. Okay, there are so many ride requests from the popular places are coming, and what this producer will do is it will like because if it keep on processing every single request, it might make the database it might make the database go slow and getting exposed to some kind of a spike. So instead of that, what it will do is it will buffer in a given area, suppose 50 requests together, and send to the right matcher service. So suppose there is a certain conglomeration of people are there, and what it will do is it will send all those 50 together, and at that particular time, if the rider and the driver matches, out of that 50, some like 1 2 3 4, it will get processed, but in a batch. Okay, so now there is we were talking about the producer buffering. So let's talk about on the broker side what happens in terms of the buffering and the batching. So like broker can also buffer messages before writing before sending it to consumer, and also before WAL or before write ahead log, it can do a buffering and batching as per needed. So a broker receive batches of the write request from multiple producers, and it buffers this request and write them to the disk in larger batches to optimize the disk usage. So this is basically optimizing memory in disk. So in this way, like broker also leverage buffering plus batching. Now I think it is clear that what exactly the buffering, the difference between the buffering and the batching is. Still, let's talk about it for some time. Suppose this user, like it sends a write request, producer buffer this request into memory. When the buffer reaches around like 100 or 100 requests per 1 second or something, like maybe in every 1 second it will try to batch something. The producer sends the batch to the broker, and on the broker side, what happens is the broker receives the batch of write request from multiple producers, and those multiple producers uh, l- uh, like uh, other than those multiple producer, before sending it to the uh, into our memory for storage like WAL, as we were talking about the write ahead logs, then also it might um, batch and buffer and batch that whole array of requests. So now let's improve the so this is basically the producer flow. Like if we think this mostly around the producer and broker flow. Okay, this is the producer and the broker flow, this part. And what if we just have to, what we are now more concerned about is the consumer flow. Okay, so let's talk about the consumer flow. So now in the producer and the broker flow, we found out that how exactly the buffering and batching happens, and what will be the behind the scenes storage pattern, that is the WAL. So these are the very basic things we figured out. And now in the consumer flow, what should we do? Like this is a question to you, whether we should be push the data to consumer or pull the data from consumer. Pull the data from broker by consumer. What should we do? And what are the pros and cons of the each model? Okay, so for push model, what will happen is when we are pushing, pushing means it is low latency. Uh, so because this thing happens immediately, like anytime any message comes, immediately we can push it. Okay, and what will be the problem of this approach? So consumer can be overwhelmed. Okay, suppose consumer might not be scaled enough to handle the plethora of data. Now let's talk about pull. So in the pull, the advantage is consumer consumer controls the flow, but the problem will be consumer might keep on pulling data even no messages are there. So most message in the queues, what we have is generally like the Kafka or many other popular message broker service that we see. Mostly this is the most popular one. Okay, so if we have to select one, during our process of designing, probably we will select the pull one, because pull, as we were talking about, this is the most popular one. Okay, now now, so how exactly the flow will be? The consumer joins a group and subscribe to a topic. Okay, so consumer here, generally like we all discuss about the topic, partitions, many things, right? So consumer, what it does is, suppose there is a topic, consumer subscribe to that topic, and the coordinator assigns that partition to the that particular uh, topics partition to a given consumer. And consumer, what will keep on tracking is, consumer generally, like in the pull based model, one more important thing is it keep on tracking of offset. So what exactly offset is? The last read message index. So suppose I have read till now, like read till now 99 offset. So even if there are not messages for some time, what we will do is it will start from 100th, and another consumer will be there. Suppose this is consumer 1 and this is consumer 2. Another consumer, it can be completely out of sync from this. What it can do is it might be having on the 1 offset, and what it will do is it will start from 62nd. Okay, so offset, pull or push message, these are the main heart of the consumer flow system. Now let's talk about the the coordinator. What this coordinator does is, coordinator, right? So what does this coordinator do? So this coordinator actually controls from which consumer, from consumer to which topic and partition the message will go. Okay, so there are like so suppose a consumer A, it is subscribing to, suppose there is a consumer A, it is subscribing to three different partitions, 1, 2, 3 and 4. Okay, and another consumer, like consumer B, then tells that, okay, I want to join you guys, I want to be a part of the same consumer group. Okay, so now what happens is, probably like based, it will be the responsibility of the coordinator service. I'm writing it as CS. What this coordinator service will do is it will tell key, okay, one consumer A, you are handling 1, 2, 3, 4. Rather, what you do is you handle 1 or 2 now, and what consumer B will be tasked to do is it will be handling 3 and 4. So in this way, we will write consumer A and consumer B. Now this coordinator notifies basically all consumer to rejoin in the group and elects a new leader and generates like the leader election and all the other system design details I'm not going into here. But in this process, like there will be one leader consumer for sure, although there are replicas, there can be replicas. So when consumer A uh, when consumer A might decide to leave. Okay, so what will happen is this one or two will come to consumer B at that point of time in case consumer A wants to leave. Okay, so this is again in the when we say consumer leaving, there can be other cases as well, like consumer crashes. Okay, so the coordinator marks the consumer as dead and triggers a rebalance. So what this coordinator does is as we were talking about this, the main point is like the rebalancing. Okay, the rebalancing of the rebalancing of the various consumer and the their partition subscription. So there is one more important concept here. Coordinator marks the consumers as dead, right? But in that case, there will be some kind of a state storage will be required. Like, so what the state storage does, it is again related to the consumer coordinator only. So let's talk about the state storage a little bit. So there is a partitions and how many consumers are associated with these partitions. Okay, like suppose consumer 1 is subscribing to partition 1, partition 2, etc. So who will keep track of this thing? This state storage system that we are talking about here, it keep a track of this thing, that producer consumer mapping, and not only that, till what offset consumer has read. So suppose like the partition as we were talking about in the other example, like this offset 99, offset 62 for the C2 and 99 for the C1, this kind of state storage tracking is being done by our consumers. Sorry, our state storage, this partition and the consumer mapping. And there is another thing important is like metadata storage. So what exactly metadata storage is? Metadata, like as many of you might understand, the term metadata is actually refers to data about data. So it is ideally the data about our brokerage system. So what exactly the primary information that we will need, that is the topic config, number of partitions, retention period, replica distribution. Metadata, and this metadata, like when this retention period is to be changed, all this thing might change, but it will rarely change. Okay, all these metadata related details. So the very primary thing that we have learned so far is we have learned about our storage. The WAL will be our storage. We have learned what will be our message schema, maybe like some immutable byte array in terms of the key value pair we will do. We learned about also batching versus buffering, and how batching plus buffering can be used here, how the partitioning will take place, that we haven't discussed yet, but where this partitions data will be taking place, that we discussed in the uh, and that is in the state storage. Now the question is how this partition will happen. Now once this data is coming, probably we should have discussed it earlier. Once this data is coming, how exactly we are going to divide it into different topics and different partitions. So there has to be some kind of a hash function, and this hash function we can store it in our metadata storage or in our any other kind of storage, and using that hash function will give us an output that which partition to select. So based on that hash function or maybe some kind of a circular function, it will keep on selecting the given partition where a particular message should be going. Now let's discuss about one of the very important thing, that is replication. So like as we were discussing the basic storage, the metadata storage, the state storage, coordinator, consumer and the producer flow, all the basic things we already covered, and now we will try to make our system more resilient. Okay, so suppose take Netflix and LinkedIn for example. Okay, so to achieve, like if I just ask you one question, like how do we make a system like more highly available and prevent data loss? Okay, so this is one of the primary motivation of replication, like how do we make a system more highly available and we can just restrict the data losses. So in that case, uh, like replication is our primary strategy that we can take. So in that case, what happens is generally we will have like the typical replication setup would look like this. So suppose there will be a topic A or a partition. I'm just using this, although they are not same, but I'm just using for our understanding. So what we are going to have is there will be a broker 1 which will be leader, and there will be broker 2, this will be follower, and there will be broker 3, this will be again follower. Okay, so follower 1 and follower 2 we can say. Now each partitions have multiple replicas distributed across different broker nodes. Okay, so producer keep on sending the message to the leader replica. So of course the leader replica will get the first, suppose the message 1, and this message 1, what it will keep on happening is it keep on getting replicated into a different followers. So why do we need this leader and follower replicas? Of course the answer is for fault tolerance, like being highly available means like it is also fault tolerant as well. In case any fault happens, it is able to tolerate that by having the leader follower kind of a architecture. So now what happens if the leader fails and then there are no followers, right? The data of the partitions will be lost. So exactly for that reason, we have multiple replicas, and we ensure that the followers are up to date with the leader. And how do we ensure this part, that followers will have always have the up to date data? So that we will, for followers, how do we make sure that that is by using like the followers will pull the data from leader. Okay, so now Netflix particularly, like this is just a know-how thing. Netflix uses a custom high throughput priority queue system called timestone, and what it does is that particular thing helps it to make it fault tolerant by copying the data from the leader broker to the other one. So and also like Netflix uses this coordination system as well to ensure that the replicas are placed on different node in a different geographical distributed location to avoid a single point of failure. Now what if a single broker fails? What will happen? Now there is something called in sync replicas will this particular thing we called as like in sync replica. So or ISR. Okay, so ISR will kick in anytime a broker fails or the leader broker fails. So the leader will keep track of which replicas are in sync. If a follower falls behind more than a configured number of messages, it is removed from that in sync replica list. And so, for example, the leader even knows that okay, follower is having all the data till this certain offset like 13, or suppose a certain offset like 10. Okay, now this isrs are very primary component of making this replication successful. And not only in the this message brokerage system, in any system, whenever we are trying to making it highly available, fault tolerant, and we are trying to prevent the data loss, this leader follower alongside the in-sync replicas, they are the very primary component of this. Now uh, let's talk about a few flag value also, which Kafka uses behind the scene. So that is being known as the ACK flag. Okay, so ACK flag people can implement in a different way. Okay, so ACK all means all ISR have received a certain message. So a certain message is flowing from producer to broker. So that means if a certain message is being sent uh, from the producer to of the broker, producer has to have an acknowledgement that all the ISRs have received a certain message. Then it is ACK all, and then some time the configuration is like ACK1. That means at least one ISR, like at least one in-sync replica is there. And ACK0 means that particular producer or like the producer broker interaction doesn't care about um, any replication. So this is just again a know-how. All these things like regarding what Netflix does, we can implement it in our own way or in a different way as well. Okay, so now let's discuss about the consumer side. Okay, so this is on the replication on the leader side. So in the consumer side replication, what happens? Okay, so in the consumer side replication, what happens is like for design simplicity, let's think about this thing. Why do consumer typically read from the where does the consumer typically read from? So consumer will always, okay, this is always from the leader replica it will read from. And why? It is for the design simplicity and limit the number of connection to the leader. Okay, so now the leader could become a bottleneck if too many consumers are there. Suppose if too many consumers are there, in that case leader may become bottlenecked. Okay, in that case leader may become bottlenecked. So by increasing the number of partitions and the distributing the consumer across them, we can handle this. Okay, so what we can do is instead of making it always reading from the leader, we can do something like lead from the ISR, where if it is completely in sync leader, it should read from leader plus in sync replicas. So that is what the consumer model is. And consumers are scaled in a way that even if a consumer fails, there will always be another consumer will be ready. And you know that, for example, a consumer is reading till a certain offset. So even if it fails, it doesn't matter. When it comes back to life, what it will do is it will start reading from that previous point only. So if we just keep on illustrating this example, like there is a certain partitions. Okay, there is a certain partition like P1, and what will happen is there is the broker 1, this is the leader, and suppose there are different brokers are there, like B2 and B3. So in case, mostly it will read from the leader, and these are ISRs. So leader, or this, from this ISR, our consumer can our consumer can read. Okay, so in this process we must always mention about zookeeper. Okay, zookeeper, no Kafka discussion is complete without zookeeper, and this is the last part that we'll be discussing. So what zookeeper does is, zookeeper is one of the most popular centralized service for maintaining the configuration information, the distributed synchronization. So again, like, centralized service for maintaining config, ISR, all the cluster metadata it maintains. So suppose a broker goes down. Okay, now who will take care of this thing? So when a broker goes down, then zookeeper will come into picture, and what it will do is, uh, it triggers a series of action that to make sure that the system is operational. Okay, so what it does is it detects the broker failure, it detects failure 1, and then what it will do is, it notify the rest of the operational brokers that, okay, this broker 1 has failed. Okay, and it gives some kind of a timeout heartbeat as well. So, and on that failed broker, whatever the data was there, it doesn't care about it. So data, as data is already replicated, what it does is a new ISR will be promoted as leader. Okay, and then it becomes operational again. Now what if a consumer goes down? Okay, now let's talk about this. What happens when a consumer goes down? When a consumer goes down, then what happens is, it starts rebalancing. Okay, so it starts about the consumer group activities. When it rebalances in a way that it redistributes the partitions. So when I say redistributes the partition means, excuse my spellings. So redistribute partition means, suppose P1 is being handled by C1. Now as C1 is down and zookeeper has those metadata, so what it will do is it will probably spin up, uh, it will ask C2 to take care of P1. Okay, so P1 is here the partition one, and it also helps on that offset management as well. So suppose P1 till offset 13 or offset 15 is being read. So what P2, like offset 15 is being read by C1, so this state is being maintained, and C1 will start processing from 16 offset. Okay, this is what exactly is being done. So how does zookeeper detects this consumer failure is, it uses, like, this consumer or brokerage failure is a simple heartbeat mechanism. So heartbeat means, like, it keep on sending some kind of a HTTP get message. If it gets some kind of a timeout, that means it is dead, and in that case those rebalancing, redistribution, promoting of the ISR, all those things happens. So this is on a very high level what Kafka does, and it's internal. So again, like, probably these are too much information, so what I will request you to do is, you can go through this video again and try to just draw your own diagrams, like how coordination happens, how consumer flow happens, how producer and broker flow happens, and what happens when a producer in a producer broker interaction, if a broker goes down, in that broker and consumer interaction, if a consumer goes down, in that case, like, there are many other popular terminologies. For example, master master replications, and there are like primary secondary replication, but all of this thing boils down to these things only, the leader follower sort of a thing. Yeah, this is pretty much it. Like, for the Kafka, this is how we can design on a very deep level. And there are, of course, some other examples or the other intricacies as well. But for the time being, like, for our uh, basic knowledge of getting a message queuing, this will be enough. So thank you very much. In case you have any question, please put that into the comment section. I will try my level best to answer that. Thank you once again.